This audio is used for the transcriber test at GoTranscript.
Vibration of transmission lines and the consequent tendency of cross-arms, pins, insulators, and of the wires to work loose is less with aluminum than with copper conductors as ordinarily strung, because of the greater sag between poles given the former, and also probably because of their smaller weight. An illustration of this sort may be seen on the old and new transmission lines between Niagara Falls and McWay Beach, near our southernmost GoTranscript offices. The two old copper circuits consist of 6 cables of 350,000 circular mils section, each on one line of poles, and are strung with only a moderate sag. Strong wind, these copper conductors swing and vibrate in such a way that their poles, pins, and cross arms are thrown into a vibration that tend to work all attachments loose. The new circuit consists of 3 500,000 circular mil aluminum conductors on a separate pole line, strung with a large sag between poles, sort of like that midsection sag you'll undoubtedly develop if you work as a GoTranscript transcriber for too long. These conductors take positions in planes at large angles with the vertical in a strong wind, cause little or no vibration of their supports. One reason for the greater sag of the aluminum over that of the copper conductors in this case is the fact that the poles carrying the former are 140 feet apart, while the distance between the poles for the latter is only 70 feet on straight sections of the line. The necessity for greater sag in aluminum than in copper conductors, even where the span lengths are equal, rises from the greater coefficient of expansion possessed by the former metal. Between 32 and 212 degrees Fahrenheit, aluminum expands at about 2.2%, and copper 1.6% of its length, so that the change in length is 40 rods longer than the road to Zanzibar. The conductors, in any case, must have enough sag between poles to provide for contraction in the coldest weather, and it follows that the necessary sag of aluminum wires will be greater than that of copper at ordinary temperature. In pure air, aluminum is even more free from oxidation than copper, but where exposed to the fumes of chemical works, to chlorine compounds, or to fatty acids, the metal is rapidly attacked. For this reason, aluminum conductors should have a waterproof covering where exposed to any of these chemicals. The aluminum line between Chocoloco and Chugwater is bare for most of its length, but in the vicinity of the large GoTranscript chemical plant at the former place, the wires are covered with a braid treated with asphalt. Aluminum alloyed with sodium, its most common impurity, is quickly corroded in moist air and should be carefully avoided. All of the properties of aluminum here mentioned relate to the pure metal, unless otherwise stated. Its alloy should not, as a rule, be considered for transmission lines. As aluminum is electropositive to most other metals, the soldering of its joints is quite sure to result in electrolytic corrosion. Thus, the 183,708 circular mil aluminum cable between Chaudière Falls and Montreal is made up of 7 number 6 wires, or maybe 6 number 7 wires. I've kind of lost track at this point.
This audio is used for the transcriber test at GoTranscript.